Okay, so now all we're gonna do right now is practice before the practice. So before we have those practice problems, let's practice together and see how quick and easy these problems can go if you actually know the rules. So in this case, we're given the leg. All right, I'm gonna write down too much right now. We're given the leg, so we automatically know that n is also 3, because that's also a leg. All right, and when given the leg, what do we do to get the hypotenuse? Well, remember the hypotenuse equals the leg times radical 2. So all I'm going to do is take this radical 3, multiply it by radical 2, and equals 3 radical 2. So really, all I would need to see is 3 radical 2 and 3. That's all we need. All right? Now again, we're going to be given different stuff each and every time, different situations. Let's just go straight across. In this case right here, again, we're given a leg. So that means y, the other leg, is 7. Again, these are isosceles triangles. They have two sides that are the same. Then all I have to do is multiply by radical 2, and that tells me that x, the hypotenuse, is 7 radical 2. All right. Now in this case right here, I'm given the hypotenuse. I'm going to write hype for hypotenuse. All right. So there's two ways to think about it. Again, you just have to identify what information you have and how do you want to go about it. Do I want to divide by radical 2 or multiply by radical 2 over 2? Well, in this particular case, since I already have a radical, let's just divide by radical 2. See how it simplifies. So I'm going to do radical 6 divided by radical 2. When you have a radical over a radical, you can just divide the numbers. You get radical 3. So in this case right here, use radical 3, v is radical 3. All right, now same thing, we're given the hypotenuse. So again, 13 is the hypotenuse, it's opposite the right angle. So moving this way, do I want to divide by radical 2 or multiply by radical 2 over 2? Well, in this case right here, I'm just going to multiply by radical 2 over 2. So x will be 13 times radical 2 over 2. All right, that's x, and then y is the same exact thing. So again, 4 examples, given different informations, sometimes given a leg, sometimes given the hypotenuse, even had a radical. Just know the rules, apply them, and these problems become very easy. If you don't know the rules, numbers become long and tedious. All right, this is something we have to study and get good at. All right, now we're going to do some word problems. All right, we're going to draw a diagram, label it, and we're going to use our rules. All right, so in sailing, it is not possible to head straight into the wind. All right, so when you're sailing, you can't go straight into the wind because the wind would push you the other way. In order to get upwind, a sailboat simply sails at an angle to the wind, then turns back and sails towards where he wants to go. Assume that the boat needs to go directly upwind 600 meters. If it sails off at a 45-degree angle to the wind and then turns back 90 degrees towards the original goal, how far would he have to sail to get 600 meters? So what it's saying here, some boat, we'll even draw this sailboat. Okay, that's my sailboat. It has to go 600 meters this way. All right, but the wind is blowing at the wrong direction, so it's going to go 45 degrees this way, then turn 90 and go that way. All right, so this is a beautiful right isosceles. So it's saying how far total does the sailboat have to go? All right, so again, right now we're given the hypotenuse. All right, it gave us the hypotenuse. So to get to the leg, I'm going to multiply by radical 2 over 2, or divide by radical 2, however you want to think about it. But it's going to say 600 times radical 2 over 2, and then just simplifies this. 600 divided by 2 is 300, so it's 300 radical 2. And over here is 300 radical 2. All right. Now, how far would it have to sail to go directly upwind 600 meters? Well, the distance it's actually trailing is the distance of these two legs added together. So the distance would be 300 radical 2 plus 300 radical 2, or also known as 600 radical 2, after you added them together. All right, so that's the exact answer. That's how far they traveled. It's good to have exact numbers, but since this is a story problem, we can say, well, approximately, make it a little bit more human sense. 8.5 meters. All right. So it's adding almost 250 more meters to its travel because the sail is going directly into it. Good sailboat problem. All right. Now, given the length of AC is equal to 8, find the area of the square. So the length of AC is 8. All right. So this is a square, so let's emphasize the square. That means that this is a 90-degree angle. And fun fact, the diagonal makes 45-degree angles. So really we just need to find the legs. All right, so to go to this way, we're going to multiply by radical 2 over 2. And again, I'm always writing or, just so you remember that, but I'm just going to use this first rule. So I'm going to have 8 times radical 2 over 2. And we're going to get 4 radical 2. All right. So that means that that's 4 radical 2. So remember, all the all the sides of the square are 4 radical 2, and we know that given the diagonal is 8. So the area of the square is just going to be 4 radical 2 squared. All right, you got to square the whole thing. So you can think of it as 4 radical 2, 4 radical 2, or 4 squared radical 2 squared, which nonetheless 16 times 2, or the area of the square is 32. So not only can we find the area of a square given a side length, we can also find the area of a square given its diagonal. Ooh, I'm feeling the power of these special right triangles. All right, and then we're just going to do 2 quick midpoint review, because why not? All right, so reviewing midpoints. All right, we still got to remember this stuff, very important. They're coming up later on in the school year. So point A is located at this, point B is located at that. Find the midpoint of AV. All right, so we have the good old midpoint formula where you add the x's together, divide by 2, add the y's together, divide by 2. A lot of times in a coordinate plane, we can just tell by counting. This case right here, no coordinate plane, and some crazy decimals. So we actually have to know this midpoint formula and plug things in. All right, so the midpoint will be negative 1.5 plus 1.2, 3.2 plus 6.7. Again, remember the midpoint formula, and then I just plugged in everything correctly. Technically, you should be able to do this problem. However, you might have forgot. And then we just got to be very careful when we add these decimals together, positives and negatives and stuff like that. And then simplify, we'll get negative 0.3 divided by 2, negative 1, oops. And then 9.9 divided by 2. All right. So that's it. That's how you do that problem. Just a midpoint formula. Add the x's together, divide by 2. Add the y's together, divide by 2. Some ugly decimals with negatives and positives. Just be careful, and you'll get what you need to get. And then this problem right here. So before we do the next problem, realize we were given 2 end points. We found midpoint. Number 2, point J is located at 0, 1. The midpoint of H is located 9, 2. Find the other endpoint Q. So here we're given endpoint / midpoint. We need to find other endpoint. All right. So again, we've done problems like this, just been a while. That's why we're brushing up on our skills. So this midpoint formula I wrote up here, I'm going to rewrite it down here. It's just going to look a little different. The specific midpoint, the x-coordinate of the endpoint is x sub m. So again, looks the same, or it's the same formula, just presented a little differently. Instead of the giant M, I'm writing x sub m and y sub m, so we can find the individual coordinates. All right, now it told us J is an endpoint, so I'm going to call that x1, y1. It told me H is a midpoint, so I'm going to call that xm, yn. Now I need to very carefully plug these things into my formula. So x sub m is 9, x sub 1 was 0, x sub 2 had no point. That's what we're finding. So that's what I set up. Now really from here, just simplify and solve. All right, so I'm going to get 9 equals x sub 2 over 2. Multiply both sides by 2. And 18 equals x. All right. So 18 is the x-coordinate of one of my endpoints. Now the other one will be the midpoint y sub m, 2. Y sub 1 was 1. Y sub 2 is what I'm finding. All right, so this one we have to simplify just a little differently. Put parentheses around that. Then I'm going to multiply both sides by 2. So I'm still multiplying both sides by 2. Do not distribute on this right-hand side. The 2's cancel each other out. All right, students like to try to distribute. That's redundant. You don't need to, or not redundant, just plain out mathematically illegal. So the midpoint for Q, the coordinates is 18,3. All right, so just some midpoint review. Fun stuff. That's the midpoint formula. Cool beans. Have a good rest of your day.